So today we're going to look at the composition of functions, but we're looking at evaluating the composition of functions. So what does this mean? Well, let's look at an example. All right, so given f of x equals 3x squared minus 2x plus 1 and g of x equals negative 2x plus 1, evaluate the following. Okay, so in part A, we're evaluating f composed with g at the value x equals 0. All right, so I guess there's two ways of doing this. We can find the composition f and g and then evaluate at x equals 0, or we can evaluate g at 0, figure out what that value is, and then evaluate f at the value g of 0. So let's do it the first way, where we find f composed with g first. Okay, so what do we get? We got 3 times gx all squared minus 2 times g of x plus 1. G of x is negative 2x plus 1, so we need to plug that in wherever we see g of x. Minus 2 times negative 2x plus 1, all plus 1. So now we can plug in 0 for x and see what we get. All right, so we got 3 times negative 2 times 0 is 0, plus 1 all squared, minus 2 times negative 2 times 0 is 0, plus 1, plus 1. And what do we get? We get 3 times 1 squared is 1, minus 2 times 1, which is 2, plus 1. So that equals 2. So that's one way of doing it. So let's, and this first way was finding the composition of the two functions and evaluating at x equals 0. So let's do the second way, where the second way we're actually going to find g evaluated at 0. So g evaluated at 0 is, let's move this over a little bit, negative 2 times 0 plus 1, I believe, and that equals 1. Yes. So g evaluated at 0 is 1. So now we plug that value, in here. So now we look at f evaluated at g at 0. G at 0 is 1. That's f at 1. So what is f at 1? 3, 1 squared minus 2 times 1 plus 1. And I'm running out of room here. Let's move this into the middle. We get 3 minus 2 plus 1. That equals 2. And that gives us the same answer that we got before. Okay. Good. So, it looks like we're looking at the same two functions again. So in part B, we're looking at f evaluated, f composed with g evaluated at 1. So again, we have our function f composed with g. Well, so why don't we use a different color? Green. So this, the green box, is our function f composed with g. So we can do it the first way. Better way to write is f composed with g evaluated at 1. So we're going to plug 1 into the function in the green box. So 3 times negative 2 plus 1 squared minus 2 times negative 2 plus 1. Oh, and then plus 1. We get 3, negative 2 plus 1 is negative 1 squared minus 2 times negative 1 plus 1. All right. And what do we get? We get 3 times 1 squared, which is just 1. 3 times 1 is 1. Negative 2 times 1 is positive 2, and then plus 1. So 3 plus 2 plus 1 is 6. Good. And then finally, part 3 is, oh, we have a few left. All right, so part 3, G evaluated at F, evaluated at 0. G. Okay. So let's write our functions G and F down. These are quite high up. All right, so let's put them down here. All right, so f at x equals 3x squared minus 2x plus 1. G of x equals negative 2x plus 1. All right, let's scroll all the way up. All right, so now we want to look at G composed with F evaluated at 0. So I think we're going to do this way. We're going to look at F evaluated at 0 first. So F evaluated at 0, what do we get? We plug 0 in for x, so we get 0 minus 0 plus 1. That's just plus 1. So we're going to plug that in here. We get G evaluated on 1. So if we plug 1 in, so we get negative 2 times 1 plus 1. What do we get? We get negative 2 plus 1, and that's just negative 1. Easy. All right. Last one, G. G evaluated, G composed with F evaluated negative 1. All right, so again, I think it is easier to evaluate F at negative 1 first. So F at negative 1 is 3 times negative 1 squared minus 2 times negative 1 plus 1. What does that equal? 3 plus 2 plus 1, that's 6. So F at negative 1 is 6. So then we plug that in, and we have G at 6. What's G at 6? Negative 2 times 6 plus 1. And that equals negative 12 plus 1, or negative 11. So it looks like the second method of evaluating the composition of two functions at a particular value is easier. At least I think it's easier. But we looked at both ways of doing it. First, we can find the composition of the two functions and then evaluate the value at x, or we can evaluate the inner function at that particular value of x and then evaluate the outer function at that new value. Good. All right, so that brings us to the end of our session. If you have any questions, send us an email at info@raisebymarks.com or give us a call day or evening, and we look forward to hearing from you. Thank you for watching.